And I think it's quite important that whenever you discuss such a price experience curve, many people would argue with you, okay, that was history, but are you sure that this is to continue for another decade in cost and price? And we did some more analysis along that, which will be discussed more tomorrow also in a presentation. That is the semiconductor. And I'm happy to have Mike here from Applied Materials have contributed to make a price experience factor of 40%. So 20% was the price reduction for the solar modules over the last 30 years by doubling humidity volume. With such a process, it's 40%. Why? Because you do have a lot of technology nodes, as you can see. These are the dimensions of the microcircuitry, which started here very large, and today we are doing that in the 20 nanometer range. Some people would argue, that's great, that's only working with semiconductors where they get smaller and smaller. Now that is flat panel displays. And you know these flat panels who are now everywhere in the room and in your home as well. And that has an astonishing 35%. Why? Because we have been able to have machinery to do a display substrate area from 0.1 square meter 20 years ago, nowadays towards 10 square meter. That is where the price experience factor is coming. And I'm always saying a module is a very simple flat panel display. So therefore I am convinced more than ever that the price experience curve for PV modules will continue at least for another order of magnitude.
So push the volume, the prices come down, you've got to work at it, or the cost comes down, you've got to work at it. So we know the industry can grow, there's no real material constraints. If we get volume, we get the economics. What does this mean? We all know also that our technology is expensive today, it's way out of the market, it's subsidized. People don't like this, and rightly so. What we looked at in the study here also is, if you just take the European markets, segment them out, the bubbles are the different segments, be it residential, commercial, industrial. And that little red curve at the top was the price of a system in Germany on the roof, about €4 last year. And we know a couple of things. With the average price of electricity, the bubbles are moving in that direction. If we get the cost curve down, we're moving in this direction. And today we're way off all markets. What happens when you just go a few years forwards? What you see is that picture changes very rapidly. If you take the 2008, that's where we were. You take 2012, and these again are on the old price and cost trends. You get to about 5, 6, 7% of total available market, economically accessible. Italy, residential, commercial, tile of the industrial, other markets are in there. It is cheaper to get electricity for the consumer than pumping the price from his photovoltaic system, from the planet. 2016, you're up to about 25%, up to 50% of the total accessible market. If you look at this, this is Germany industrial. This is where accelerated cost can take us. This is huge potential. Economically, within the next years up to 2020, somewhere over 60% of electricity demand can be economically better achieved by photovoltaics. And that creates a lot of value, obviously. Perhaps one of the also very, very interesting aspects of this study is the following. And then people always come back with the next argument, but we've got to do feed-in tariffs and this is going to cost. And we looked at this, and if you look at this on a macroeconomic scale, taking the envelope Europe, for example, you come to the following conclusion, non-intuitive. What does this save you? What does this cost you? First of all, you save a lot of CO2. We've estimated that out conservatively. That's this 1.2 cents per kilowatt hour. We've got reduced grid losses because we're producing decentrally. That helps us a little bit, 0.5. And then you have a big, big block in terms of hedging value. We know electricity prices are going up. You know what happened to oil when a little bit of the demand spike came in. Which takes us up, we'll get back onto this number. See, that's a tough one to estimate, somewhere between 1.5 and 3 cents. I think we will talk about this in a moment, and then we have costs. We will have operating reserves. We'll have to keep other capacities in the world, in Europe, because the sun doesn't always shine, and we still haven't quite figured out how to make electricity from photovoltaics at night. So we need baseload capacity, which will be idle. That's going to cost us about 1 cent there, and there'll be value loss in utility margins of about 1.6. But using photovoltaic will get us a net value of about 3 cents a kilowatt hour. The one we get attacked on, I think, when Fred, is this hedging value. Could you say that a bit? That looks a bit high, doesn't it?
That indeed was a discussion which I had over the last couple of weeks very heavily with many in the sector. And indeed, a hedging factor, by the way, it was developed about 3 years ago by Landesbank Baden-Württemberg, LBBW, and they introduced that, saying if you install a system today, photovoltaic system, then as you get really warranties for the modules and everything, so you know your generation cost is fixed for the next at least 20, more realistically even 25 plus years. And that obviously assuming that there is an increase in normal electricity prices, that has a value, and that is this hedging value. So I looked around at many people, and it took me some time, and I was just able last week, so just in time for this presentation here, from Südweststrom, and I was even allowed to use that in a public way. And this is how the utilities for baseload electricity and peak electricity are assuming what the price development will be on the long term, from starting here in 2014, 2035, 2000, even in the 40s range. And that is what they assume as an increase. Now, if you take a closer look to that, for the baseload, they expect a delta of about 2 cents a kilowatt hour over 20 years' time. Now, that is a gradual increase. The hedging value here would be just 1 cent a kilowatt hour. If you go to the more peak load, then the delta is 3 cents a kilowatt hour as a total delta. So if you smear it out continuously, that is a hedging value of 1.5 cents a kilowatt hour. And if you remember what Anton just showed, this is the 1.5 cents which we used in addition to just the 3.1. Now, I discussed with the utility people here what is happening in Europe as we will have liberalization of the utility market, and US is a good example. They have in most of their municipalities, they have already a liberalized market. And in such markets, your prices to private households are in times where you have peak load much higher than what we pay as a flat rate. And in California, for example, that is in the range of 20, 30, 35 cents a kilowatt hour in the afternoon and in summer, because that is where the peak is occurring. So if we take that into account, and knowing that Europe in the next 10 years will move towards a liberalized market also, so we will even have another curve here in the future, which tells you what is the price development for peak load in the afternoon in summer, where photovoltaics, obviously, will contribute most of its produced kilowatt hours. So that hedging value will even be above that 1.5. So it is very realistic to assume something in the range of 1.5 to the 3.1 cents a kilowatt hour, which were proposed by LBBW. So I think this is a very nice explanation why such a hedging value in that value is really realistic.